using 2 steps to solve an equation with whole numbers. All right, so we have the equation 26 equals 3u minus 16, and we're trying to solve for u. I want to get u by itself, which means I need to slowly peel off the layers surrounding u. We want to be really careful when we're solving equations. There's a lot of places we can go wrong here. I like to personally draw a line that I call the wall underneath my equal sign. Anything that you do on one side of the equal sign, you have to do to the other. So if I wanted to, let's say, like subtract 5 from 26 for some reason, I would have to subtract it from this side as well. You want to make sure there's something happening on both sides of the equal sign, not just on one. So if I'm looking at this 3u minus 16 and I want to get the u by itself, we're going to focus on the 16 first. You can't get rid of this 3 next to the u very easily. This needs to be by itself before you can take care of it. We're trying to undo things. So if I see a minus 16 and I want to get rid of it, I'm going to add 16. Once again, we can't do this with just one side. If we add 16 to one side, which will cancel it, we need to add 16 to the other side as well. 26 plus 16 is 42. My equal sign is on the wall. And then we have 3u that just kind of comes straight down. Once you have the variable by itself with a coefficient, all you have to do is divide by the coefficient to get u by itself. So I'm going to divide both sides by 3. That cancels these 3's out. 42 divided by 3, you'll probably want to use your calculator for that. That's going to be 14. So we get 14 is equal to u, which oftentimes we will write as u equals 14. Now you can always check your answer by taking this number and plugging it back in for u up here to see if you get a true statement. I'm not going to do that on every problem, but I am going to do it right now to show you what that looks like. So you have 26 equals 3, and then instead of u, I'm doing 14 because that was my u. It's multiplication because they're right next to each other, and then minus 16. So 26 is equal to, on my calculator, I could do 3 times 14 and find out that it's 42 minus 16. And then again on your calculator, you could do 42 minus 16 and see that you get 26. And because you have 26 equals 26, you have a correct answer. You will know your answer is incorrect if you get 2 different numbers. So if maybe I thought the answer was supposed to be 5, and I plugged in 5 instead, I would have 3 times 5 is 15 minus 16. I would have 26 equals negative 1. That would let me know that 5 is not the answer. So an incorrect answer, when you plug it back in, is going to give you a false statement, whereas a correct answer will give you a true statement. Let's go ahead and do another example. So we have w over 2 minus 15 equals 28. At the equal sign, I'm going to draw myself a wall. This w over 2 can't be taken care of until I take care of the party crasher, which is this minus 15. To get rid of a negative 15, we want to do the opposite sign. So if it's a negative 15, you want to add 15 to both sides. Right. So these 15s will cancel themselves out. The w over 2 will come down. So w over 2 is equal to 28 plus 15 is 43. And now I have w over 2 is equal to 43. If you had, in this other case over here, 3u is equal to a number, we divide by 3. But if you have a number in the denominator right underneath your variable, instead of dividing both sides by that number, you multiply both sides by that number. When you multiply by 2 here, it ends up canceling those 2's out. What's really happening is you're taking 2 over 1 and you're multiplying by w over 2, and that's why these 2's end up canceling. So you get w over 1, which is just w. We don't write this stuff out because it's a little tedious to write out, but that's the reasoning behind it. So I'm multiplying by 2 on this side. that's going to give me W equal to 43 times 2 is going to be 86. So W is equal to 86. Let's go ahead and do one last example for good measure. And once again, you can always check your answer by plugging that number that you got back in. All right, my equal sign, I'm going to draw a wall. I have 4v plus 16 equals 52. I can't take care of the 4v until I've taken care of the plus 16 first. So I'm going to begin by subtracting 16 from both sides because it was a positive 16. That's why I'm subtracting. These cancel. On the left, I'm left with 4v. He just came straight down. And then 52 minus 16, I'm going to just plug that into my calculator and get 36. Now, because it's 4v and not v over 4, we want to divide by 4 to cancel. 36 divided by 4 is 9, so we get a final answer of v equals 9. So to kind of recap here, the really important thing is that you're taking care of this addition or subtraction part first on the side that the variable's on. So if the variable's on the left side, you're trying to take care of the addition or subtraction part on the left side. You want to get it so that it's just the variable by itself with a number, just like attached to it, and then you can finish off the problem from there. And that's all there is to it.